So let's try to gain some time here. And let's use a Snow Backend this time. And I'm going to ask him to produce 8 additional R sessions. How can I ask him? Well, I create the backend using this function, as we have seen before. And with the workers argument, I can specify how many additional R sessions I want to create. So I create this backend, I give it a name. So as you can see, I'm asking him here to create 8 additional R sessions. This number depends on your computer. So you typically takes a number that your computer can handle. And how do you know which numbers your computer can handle? Well, the number depends on the number of cores that your computer has. And how can you see that? Well, for that you can load this package and you can run this function and it will tell me that I have 16 cores in my computer. So if you have 16 cores, then you can easily use 8 of them for R. Or you can create one additional R session per core on your computer. So if you have 8 cores on your computer, you can create 8 additional R sessions. As you can see, I am creating less workers than I have cores, which is also fine. What is impossible, however, is creating more workers than you have cores on your computer. Okay, and then we will run the same code again. We will use bpapply to do things in parallel. This time I specify the Snow backend that I have created here as the backend that he should use. So this time he should do things in parallel. You see that there's one additional line of code that is different from the previous times, and that's this one, the require MS example. Well, as I explained, the Snow backend will create additional R sessions, but it will need to send the data to these additional R sessions, and it will need to load the packages in these additional R sessions, and that's exactly what require is doing. So it will tell the additional R sessions that are created that they need to load this package. Okay, let's run the code. So you see that a lot of things are happening here. Or what you see here is the fact that he is loading this package in each of the additional R sessions that he has created. And here is our result. So you see that it's indeed faster than the serial execution. There's not a big difference here, but that's because we're only working with 1,000 spectra. If we're going to do this for 1,000,000 spectra, you will see a very clear difference in speed. So transfer of the data is not explicitly stated, as you can see here. So this happens automatically. So bpapply will automatically transfer the data to each of the additional R sessions that is created. For this reason, it might not be a good idea to do this for a low number of spectra. Because if you only have like 100 spectra, for instance, then it will take more time to load the data into all the additional R sessions that are created. So in that case, if the number of spectra is low, then the time of doing it in parallel will actually be higher than the time of doing it in a serial way. Sometimes the communication between the R sessions via these socket connections are blocked because of network settings on your computer. This is the biggest source of bugs when you work with BIOS-C parallel. So if you try to do this and you get unexpected errors, then probably this is the cause. You see that it works, the code. I can plot a peak picked spectrum.